Hello everybody, this is Mr. Yan. This is the video for 8.6a. Remember to watch this video after and only after you have done as much of the lesson as you can on your own, and then you're watching it to check your work or review where you got stuck. If you're just watching the video to get the answers without trying anything on your own, that's kind of like cheating, so don't be a cheater. Okay. Let's take a look at 1a. We know that Rebecca's property value starts at $150,000, and each year it increases by 6%. Remember that if something's increasing by 6%, that's like multiplying something by 106%. 106% as a decimal is 1.06. So our common ratio is 1.06. That's what's being multiplied to the previous year to get to the next year. To find year 3, all I have to do is multiply the year 2 value by the common ratio of 1.06. Let's try that in the calculator. I'm going to take 168,540 and multiply it by 1.06. 168,540 multiplied by 1.06. And I get this amount here. I can copy and paste that number. Oops. Got more than I needed there. Let's try this again. There we go. Just a little bit smaller. Then to find year 4, I can take year 3, multiply that value by 1.06 again, it's the common ratio. And I get this number here. I can copy that and paste it in, make it a little bit smaller so the table just looks nice. Okay, so now I filled out the table showing the 6% increase each year. To write an explicit function based on this table, I'm going to take the format for an explicit exponential function, paste that in here. I know that this first number, this b value, has to be the y-intercept, the 0 term. So at year 0, the property is worth $150,000. Then the common ratio is 1.06 because every year it's being multiplied by 1.06 to get to the next year. Now I have my exponential function for Rebecca. Let's take a look at Jeremy. I know that Jeremy's property is similar to Rebecca's, except every year his property value is $30,000 more than whatever Rebecca's was for a given year. So at year 0, instead of 150,000, I just have to add 30,000 on top of that, which would bring me to 180,000. Year 2, add 30,000 to this number, and that would give me 189,000. And I continue this pattern of adding 30,000 to each year of Rebecca's. So this would bring me to 198,540 and 208,652. Last one, 219,371.54. All right. So 2a is asking, based on the table, is the value of Jeremy's property also increasing by 6% each year? Now, it's very tempting to say, yes, it is increasing by 6% because Rebecca's was increasing by 6%. But we actually have to check what the ratio is between each year. So between year 0 and year 1, it's going from 180,000 to 189,000. Let's figure out what the ratio is between those 2 years. I'm going to work backwards. I'm going to divide 189,000 by 180,000. 189,000 divided by 180,000. Oops, forgot the thousands. 1, 2, 3. Here we go. Okay, so the ratio between the first 2 years is actually 1.05. 180,000 times 1.05 gets me to 189,000. So already I know this is not a 6% increase because we're not multiplying by 1.06 between each term. So I can say, no, it is not increasing by 6% a year. No, because the common ratio between each year is not 1.06. So it's not increasing by 6%. 2b says, can Jeremy's property value be modeled with a common ratio? Explain why or why not. Common ratio means we are multiplying by the exact same number between each year to get to the next year. We know that between year 0 and year 1, it's being multiplied by 1.05. Let's see if the difference between year 1 and year 2 is also a ratio of 1.05. So I'm going to divide year 2 by year 1 to see what the ratio is. So 198,540, 198,540 divided by year 2 was 189,000 equals, okay, so it's very close to 1.05, but it's actually a slightly different number. So I'm just going to round this to the nearest, what is this, tens, hundreds, thousands, the 10th thousands place. So 1.0505. 1.0505. Okay, so just from looking at the first 3 years, we see that there isn't a common ratio because we're not multiplying by the exact same number to get to each term. So there is not a common ratio. Because you are not multiplying by the same number between each year. Okay. 3a. How could you transform Rebecca's function so that it is on Jeremy's function? Rebecca's function is this red curve. Jeremy's function is this blue curve. We know that Jeremy's property value is always 30,000 more than Rebecca's. And we see that in the graph too, that Jeremy's curve is always 30,000 units above Rebecca's. So what I would have to do to Rebecca's curve so that it's on top of Jeremy's curve is I would have to translate Rebecca's function 30,000 units up. And then it'll be right on top of Jeremy's. Next, write an equation for the value of Jeremy's house as a transformation from Rebecca's equation. So we know that if we're doing a transformation function, I'm going to include both of the functions in the equation. So Jeremy's is equal to Rebecca's, except I have to think to myself, well, what has to happen to Rebecca's so that it's equal to Jeremy's? Well, I know that Rebecca's function has to be moved 30,000 units up. So that's the same thing as adding 30,000 to Rebecca's function. So the way that you can read this is Jeremy's property value is always equal to whatever Rebecca's is at a given year, but it's $30,000 more than that. Last question, to write an explicit function for Jeremy's property. And we're going to modify Rebecca's explicit function to do that. So let's go back one slide to Rebecca's explicit function. We did that here. So I'm going to take this function And I'm going to start with that. So I now have Jeremy's property value is equal to the same function as Rebecca's, except we know from our information here that it's Rebecca's, but plus 30,000. So this part right here is Rebecca's function. So all I have to do to get to Jeremy's value is add 30,000 more to it. So now this is the correct explicit form for Jeremy's function. And that's all.